Hello everyone, this is Shivraj Gurjar and today we'll start ordinary differential equation. This is one of the easiest chapter in paper 1 in fact. Okay, and this is very important in the sense that it is used in almost every chapter. So we can say that this is like Article 32, soul and conscience of the constitution. Like that we can say that this is the soul and conscience of mathematics, because everywhere we'll be using differential equations, be it fluid, we have used there as well. uh, any chapter, be it calculus, there also will use some integration where we the differentiation and integral sign and all those stuff. So we'll explicitly or implicitly this chapter will be used in everywhere in fact. ठीक है. uh, ये जैसे मैकेनिक्स हो गई, there also this is useful. ठीक है. More importantly in the small oscillations which we solve through the Lagrangian method. Once a question has been asked on that also, I will discuss that. So all those stuffs will use this. We have used this in fact. ठीक है. So let us understand this chapter. ठीक है. तो इसमें जो syllabus में है, this is a CSE syllabus. ठीक है. What is it? In it, formulation of differential equations. ठीक है. This portion. Questions are generally asked from this part as well. ठीक है. Equation of first order and first degree. Integrating factor, this part is also important, and some tricky questions are involved here. Orthogonal trajectories, yes, this is also important. Very often questions are asked from here, and in fact this has multiple uses. Like orthogonal trajectory, I have already discussed complex analysis. There we have studied CR equation, Cauchy-Riemann equations. Like if fz can be written as u plus iota v, we know that if fz is analytic, then u and v are, u will be complex conjugate of v and the other way around. Okay, so in that what happens that u and v are, if we take a surface u equals to c and v equals to c2, then these are the surface which will be orthogonal to each other. ठीक है. तो इसकी ये भी यूजफुल है. ठीक है. orthogonal, indirectly if u is given, we can get this trajectory by the differential equation method as well, and even with the CR equation. Okay. Okay, in fluid also this has its uses. We will discuss in fact that. Then comes equation of first order but not of first degree. Okay, like it may be quadratic and involvement of p. ठीक है. Clairaut's form, this is also important. Clairaut's questions are also often asked. ठीक है. Singular solutions, ठीक है. We'll discuss all this. Then second and higher order linear equation with constant coefficients. Okay. Complementary functions, particular integral, and general solution. Then we have second order linear equation with variable coefficient. There are 4-5 methods to solve these, which are part of our syllabus. So we'll go one by one, and this is also a regular occurrence in the paper. In fact, variation of parameter is most favorite. It comes regularly. ठीक है. Then there is other methods as well. We'll discuss those. Euler-Cauchy equation. This is also important and easy concept. Determination of complete solution when one solution is known using method of variation of parameters. Yeah, this will discuss Laplace and inverse Laplace and their properties. Laplace transformation of elementary functions. Only elementary functions Laplace is in our syllabus. ठीक है. Application to initial value problems for second order linear equation with constant coefficient. ठीक है. This part is also important. We have to solve these differential equations with the help of Laplace. Okay. Reference book for this chapter will use this ordinary and partial differential equations by M.D. Raisingania. ठीक है. This is a good book, but this is very bulky. Some selected chapter are only needed from that. ठीक है. So I will basically tell in the respective chapter lectures which exercise to be attempted from this book. Okay, so let us start the discussion. Ordinary differential equation. First let us see what is differential equation. Okay, differential equation. Before that, let us know one thing. Differential coefficient, or also known as differential operator. Differential operator, ठीक है. So basically मान लो this is y is some function of x, ठीक है. Y is a function of x, then we say that x is independent variable, and this y, this is independent because we can take any value we wish for x. Like if we take x equals to 1, then y will be f1. Means we can change values of x, but then y will automatically be fixed. So y is depending on x. Okay, so that's why y is known as dependent variable. Okay, dependent variable. This is dependent on x, so this is a dependent variable. Yeah. Now, if we differentiate this dependent variable with respect to independent variable, we also denote this by dash f dash x. Okay, so this differentiation, this is known as differential coefficient or differential operator. Okay, this simply d over dx, this we have applied over y. So this d over dx part is known as differential coefficient or differential operator. Okay, so this is one thing. Now by the use of this only we'll see. Okay, so what is differential equation then? Differential equation. देखो, equation means there will be equality involved in it. ठीक है. So an equation involving dependent variable, independent variable, and differential operator of dependent variable with respect to independent variable is known as differential equation. ठीक है. So any equation involving dependent variable, independent variable, and differentiation of dependent variable with respect to independent variable, all these things are involved in an equation, then that equation is known as differential equation. For example, let us say that x square plus y dy over dx plus y square dqy over dx cube equals to gx. ठीक है. So this we say that this is differential equation because why it is so. Let us assume that y is a function of x. ठीक है. So here the independent variable is x and dependent variable is y, and d over dx is a differential operator. So this is a differential operator with respect to y, and this is also again differential operator. So because this equation involves all these things, so we'll say that this is a differential equation. If a equation involve only x and y, then this won't be a differential equation. For differential equation to be differential equation, it has to have differential operators. Okay, so this is one thing. Now this differential equation again is classified among two lines. Differential equation, first is ordinary differential equation and second is partial differential equation. Okay, so let us see what is OD, ordinary differential equation. ठीक है. देखो, let us say that this is a function y equals to fx. ठीक है. If there is only one independent variable, okay, only one independent variable here, this is x, and the equation involve only the differential operator of type dy over dx, d square y over dx square dny over dxn or xy, let us say this is some function of this. If this sort of equation is there, then this is ordinary differential equation, because here the independent variable is only one. So when differential coefficient of a dependent variable with respect to only single independent variable are involved in equation, then we say that that is an ordinary differential equation. In case of partial differential equation, there will be more than one independent variables. Okay. So partial differential equation will be of this form. Like let's say z is independent variable. And x and y are independent variable. Then we'll have del z over del x, del z over del y, del square z, del x square, del square z, del x, del y, and so on. This type के. Okay, so here we have two independent variable x and y, and the dependent variable is being differentiated with respect to these two. So whenever there are more than one independent variable and the differential operator of dependent variable with respect to more than one independent variable is involved in the equation, then we say that that equation is partial differential equation. ठीक है. सो ये थ्योरेटिकल चीज़ें हो गई. ठीक है, इन पे तो वैसे कुछ क्वेश्चन आना है नहीं, बट दिस वी मस्ट नो